So now we're going to talk about rectilinear motion. Anti-differentiation is useful in analyzing the motion of an object moving in a straight line. We can recall that an object has a position function, s equals f of t, and the velocity function is v of t equals s prime of t. This means that the position function is an antiderivative of the velocity function. Likewise, the acceleration function is a of t equals v prime of t. So the velocity function is an antiderivative of the acceleration. If the acceleration and the initial values s of 0 and v of 0 are known, then the position function can be found by antidifferentiation twice. Sorry for my pronunciation. So moving on to an example of this, I'll give you guys a second to write this down while I say it. But example 6 is a particle moves in a straight line and has acceleration given by a of t equals 6t plus 4. Its initial velocity is v of 0 equals negative 6 centimeters per second, and its initial displacement is s of 0 equals 9 centimeters. Find its position function s of t. Well, for this, v prime of t equals a of t. So let's start by getting the first antiderivative. And we can do this by how we've been doing it this whole class. So v of t equals 6 times t 1 plus 1 over 1 plus 1 plus 4t plus c. Then we can clean it up by doing 6t squared over 2 plus 4t plus c, which then gives us v of t equals 3t squared plus 4t plus c. Now, we are able to find c since v of 0 was given to us. v of 0 equals negative 6. So then we can plug it in, and it gives us 3 of 0 squared plus 4 of 0 plus c equals negative 6. And clearly, c will equal negative 6. Now, since we now have v of t, we can use this to get s of t because s prime of t equals v of t. So let's get the second antiderivative. We're going to do the same steps we did to get v of t, which will be 3 times t to the 2 plus 1 over 2 plus 1 plus 4 times t to the 1 plus 1 all over 1 plus 1 minus 6t since we plugged in the c plus d, our new constant. We can simplify this by crossing out the 3 over 3 and it leaves t cubed plus crossing out the 4 over 2, which leaves us with 2 squared minus 6t plus d gives us s of t. I'll give a second to catch up. So we also know that s of 0 equals 9. So we're going to plug in again and get 0 cubed plus 2 times 0 squared minus 6 times 0 plus our constant d equals 9, which gives us d equals 9. Now, to get our final, all we have to do is plug everything in, and we get, s of t equals t cubed plus t squared minus 6t plus 9. So, as an introduction for the next example, we need to know that an object near the surface of the Earth is subject to a gravitational force that produces a downward acceleration denoted by g. For motion close to the ground, we may assume that g is a constant. its value being about 9.8 meters per second squared, or if you're using feet in your problem, then it's 32 feet per second squared. So we're going to move on to our last example. Example 7 says that a ball is thrown upward with a speed of 48 feet per second from the edge of a cliff 432 feet above the ground. Find its height above the ground t seconds later. When does it hit the ground? I'll give a second to write. So we know that motion is vertical, and since it's upwards, it's going to be positive. We also know at time t, the distance above the ground is s of t. We also know that the velocity v of t is decreasing. Therefore, the acceleration must be negative. So this will help us start. Now that we have our acceleration, we can write our equation as a of t equal to dv over d of t in relation to time equals negative 32 since we are using feet. We're going to take the antiderivative to get v of t. And this is the most easy one, so you just do v of t equals negative 32, t plus c are constant. And we know that v of 0 equals 48 feet per second. So v of 0 equals negative 32 times 0 plus c, which then gives us c equals 48. We can plug this back in to get our final v of t equation, which would be v of t equals negative 32t plus 48. And then the max height is when v of t equals 0. So we set it equal to 0. So 0 equals negative 32t plus 48, solving for t. And we get t equals 1.5 seconds. I'll leave this up so you guys have time. Moving on to the second part. Since s of t, drag this down, since s of t equals v of t, we're going to take the antiderivative again to get s of t. So when we do that, using the same method we have been, we get negative 32 times t to the 1 plus 1 over 1 plus 1 plus 48t plus d equals negative 32 t squared over 2 plus 48t plus d. Then we can rewrite it and clean it as s of t equals negative 16t squared plus 48t plus our constant d. We know that s of 0 equals 432. So without even plugging in, even though we can, we know that d will equal 432, which gives us our full equation for s of t, which is s of t equals negative 16t squared plus 48t plus 432. This equation is good until the ball hits the ground when s of t equals 0. So when setting this equal to 0, we see that 0 equals negative 16t squared plus 48t plus 432. Now, we can factor out a negative 16 of this to get t squared minus 3t minus 27. And realistically, 0 is divided by negative 16 to get rid of that, but we don't need to write that step out. So this actually does not factor nicely, so we're going to have to use the quadratic formula, which is t equals, I say, opposite of b, or negative b, plus or minus the square root of b squared minus 4ac, all over 2a. And when we plug in our factors, we get negative of negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 27, all over 2 times 1. When we simplify this a little more and do some calculations, we get t equals 3 plus or minus the square root of 9 plus 108 all over 2, which then goes to 3 plus or minus the square root of 117 all over 2. And we can take out a 9 from the 117, which gives us a 3 in front of the radical, giving us 3 plus or minus 3 square root 13 all over 2. And we know that time is not negative, so that gets rid of the plus or minus, and it leaves it to plus. So the ball hits the ground around 3 plus 3 square root 13 over 2, which is about 6.9 seconds. The graph above shows the position of the function of the ball from example 7. It shows the conclusion that we met, which is that the ball reaches a maximum after 1.5 seconds and it hits the ground around 6.9 seconds.